Hello guys, welcome back to this channel. Today in this video we will be talking about apogamy and apospory in bryophytes. So starting with the apogamy, what is apogamy? Apo means away and gamy means gametes, or you can say gametic fusion. Gametic fusion, which is also called as fertilization. And apospory means here again apo is away, and spory means spores or formation of spores. Okay, spore formation. So these are two types of reproduction which are found in bryophytes. I know this may not be making much sense, so we will look at the normal life cycle of bryophytes and we will understand these two terms better. So, so we know that bryophytes show alternation of generation. Alternation of generations. That means you have a generation G1 which is followed by G2, and this G2 is in turn followed by again G1 followed by G2. And in case of bryophytes, we have two generations. One is the sporophytic generation, which is diploid, and we have a gametophytic generation, which is haploid. Okay, and these gametophytes form gametes. Female gametophyte will form female gamete, which is called egg, and male gametophyte forms sperm or male gamete. Okay, these sperms, these gametes are formed on specialized organs which are called sex organs. The male sex organ is called entheridium and female sex organ is called archegonium. Okay, one of the sperms, one of the egg are formed. Then there is time for fertilization. How that fertilization happens? The sperms are transported to the egg via water. That's why these bryophytes are also called as amphibians of the plant kingdom. Okay, this water is necessary for fertilization in these organisms. So one is this sperm here, as you can see, it reaches to the egg and results in the formation of a diploid cell called as a zygote, which gives rise to embryo. And this embryo then grows into a sporophyte, which is diploid. And this sporophyte develops on the female gamete itself, and it consists of a bulbous foot. It's called foot, and it has a stalk, which is called a seta, and it also has sporogonium, or which is called capsule. Okay, this capsule consists of spores or spore mother cells, spore mother cells, which undergo meiosis and results in the formation of haploid spores. Okay, these spores then undergo mitosis to produce as many spores as possible in order to produce more gametophytes. Okay, so this is the normal life cycle of a bryophyte, where this haploid generation is followed by diploid generation, diploid sporophyte, and this cycle goes on. What about apogamy now? In case of apogamy, as I said, this is away from gamete formation or gamete union. So you have a male gametophyte or a female gametophyte, it directly gives rise to a sporophyte. Okay, and that sporophyte will be haploid. Sporophyte, you have a sporophyte, but haploid because it directly grows from gametophyte. Because gametophyte is N, so the sporophyte, resulting sporophyte will also be N. What about apospory? Apospory means away from spores. So these spores are not produced here. Instead, the sporophyte, this diploid sporophyte, directly gives rise to gametophyte. So in this case, what will be the haploidy of gametophyte? Of course, it will be diploid. Diploid gametophyte. Okay, so let me repeat it once again. Apogamy, you have a gametophyte, which is N. It gives rise to haploid sporophyte because no fertilization takes place. While as in case of apospory, let me write it here, apospory, what happens? You have a sporophyte, which is 2N. And this sporophyte does not produce spores, means no meiosis. No meiosis. and gives rise to the gametophyte. Gametophyte, which is 2n. Okay. I hope this made some sense now. If it did, so kindly like this video, share it with your friends, and also consider subscribing to get more videos. So I hope to see you in the next video. Till then, take care. Bye bye.